My name is Kevin Kearney from EBLANA Photonics. Here to talk to you about our company, what we do, and how we might be able to help you. First of all, I'd like to thank Carlos and the Epic and Fleet Events teams for the event so far. It seems to be a great success, and a lot of interesting presentations so far. And long may that continue. Hopefully, we'll have a great day today and tomorrow. So just to introduce a little bit about EBLANA, and I'll go through, our technology, what we do, how we do it, and then if there's any questions at the end, we can go through those. So a little bit of background on EBLANA. Some of you may know, some of you may not. EBLANA is we are a laser manufacturing company based in Dublin in Ireland. We were established in 2001. And that actually makes this year our 20th anniversary year. So we're hoping for a good one, as I'm sure you all are as well. So the company was founded to commercialize some technology that was developed jointly between the Tyndall Institute in Cork here in Ireland and Trinity College in Dublin. And we are based mainly in Dunleary here, just south of Dublin. And also we have some people working off-site in countries around the world. Like I said, we were established in 2001, and the principal reason for the establishment of the company was to commercialize this technology that I mentioned before, called Discrete Mode technology. It's our own patented single mode laser design. Initially, the market areas that we were targeting were metro and access telecoms networks. The idea being to commercially produce a less expensive, a more cost-effective DFB equivalent laser for these markets. This obviously this time was a very difficult period for the telecoms industry, and to an extent it was difficult for a company as small as ours to establish ourselves in that market. So about 7 or 8 years ago, we looked at some alternative uses for the technology that we had developed in terms of other applications, other market areas, and we started to expand the portfolio of lasers that we offer. So as you can see here, we started off in the principal telecoms bands, and we have expanded that quite dramatically since then to cover most of the near infrared range. We're also actively targeting shorter wavelengths in the visible space and also into the mid-infrared in order to expand the range of markets that we serve. So at the moment, our range spans from 657 all the way up to 2.3 microns, targeting a range of different markets, including trace gas sensing, environmental monitoring, LIDAR, quantum optics, and also we are remaining quite active in the telecoms area. So just to explain a little bit about the technology behind what we do. So the discrete mode laser, or DM laser, starts as a basic Fabry Pérot laser structure. Single wavelength operation is achieved by introducing index perturbations in the form of etched features positioned at a number of sites distributed along the ridge waveguide. These features are fabricated using E-beam lithography. We use no regrowth in our laser structures. This is all surface lithography on a basic FP ridge waveguide structure. The single mode emission wavelength then is determined by the pattern of index perturbations. So you can see here on the left, the FP spectrum with the equivalent DM spectrum on the right. You can still see the FP cavity modes highly suppressed then as a result of the index perturbations which are introduced by the slots. As I mentioned, this is achieved using surface level lithography. So it's a highly accurate process, introduces loss conditions for all FP modes except for the targeted wavelength of interest. And it leads to high spectral purity and extremely good repeatability in terms of wavelength selection, in terms of consistency, in terms of SMSR. Essentially, what we're looking at is an equivalent to DFB performance, but using a a more flexible and more reliable manufacturing process that yields good results in terms of consistency and uniformity. You can see here a close up of the structure on the ridge. So this is the etched slots. It's a higher order grading, which has certain advantages at shorter wavelengths as well, due to the spacing between the slots. So one of the probably our principal market at the moment is gas sensing. So obviously that's a broad category. So there's a number of different markets within that space that we're most active in. Certainly one of them would be in gas pipelines monitoring, environmental monitoring in general, process optimization, that kind of thing. So you saw earlier on one of the slides the range of wavelengths we provide, and the different molecules, different gases that we are targeting for these applications. So the discrete mode laser, the operation and manufacture of discrete mode laser is ideal for serving this kind of market due to the precise wavelength control we can achieve and the ease at which we can design custom wavelengths on any particular wafer run. So we are able to target, particular gas wavelengths that might be more inaccessible to other laser manufacturers, or that might be a more unusual choice of wavelength for that particular application. We are quite established in a number of these markets at volume, particularly in China. We are one of the largest, if not the largest, supplier of lasers into the gas pipeline monitoring and coal mine safety markets in the world. Our 1654 nanometer DM laser for methane monitoring is one of our main products in this area. And we are capable of producing these lasers at more or less any wavelength within the 650 to the 2.3, 2.4 nanometer range. So just to give a little heads up on new products that have been introduced in the last few months. So we are now actually providing laser diodes at 760 nanometers for oxygen sensing. This is something that's been in development for quite a while and is now available on a commercial basis. We've achieved very, very good performance in terms of spectral purity, in terms of tuning for these devices, and we're targeting a number of markets, including process control, combustion, and also medical applications as well. Another new product that has established itself a little bit before the oxygen sensing laser is the 2327 nanometer discrete mode laser. So this product was introduced relatively recently, targeting CO sensing market, so carbon monoxide sensing, and is currently the longest wavelength device that we are producing, although we are obviously on the roadmap looking at devices longer than this. But this is also available in a number of packaging formats, so we can provide these in standard telecoms butterfly style, or a number of different TO packages, both with and without thermoelectric cooling. So this device, as I mentioned, is now available, targeting the CO sensing market. An additional benefit to discrete mode lasers, beyond the gas sensing market, an additional benefit that yields some some good results for, say, LIDAR applications is the fact that a discrete mode laser will have an equivalently narrow line width compared to a DFB laser of a similar design. This is due to the particular design of the DM laser with respect to how it lasers versus a DFB. So we have demonstrated extremely narrow line widths from a monolithic chip, so with no external cavity, with very little sensitivity to external vibrations and so on, as low as 70 kilohertz and below. We have a fully commercial product on the market with a free running line width of 100 kilohertz that is used extensively in LIDAR applications and fiber sensing applications. In addition to these devices, we are active in a number of different areas in terms of research and development for custom devices. So in addition to our discrete mode laser portfolio and FP laser diodes, we are also active in terms of producing superluminescent diodes, We have a number of custom laser diode designs with integrated SOA sections, with integrated MMI couplers and SOA sections and array type devices, among many other different device types. So please do get in touch if any of this is relevant to your company's work, or you think we might be able to help you. Please do get in touch. Finally, if you are sticking around the show, please do come visit our booth. A number of our sales team will be on hand to chat with you and answer any questions you might have. I will be able to answer any questions that you might have now in the chat window here. So please feel free to ask any questions below or catch me at the booth after the talk. Thank you very much.